In this section, we are going to discuss what are electrolytes, why they are important. We're going to also talk about solubility and things that affect it. So as you guys can see here, maybe the term electrolytes you have seen in commercials. So every time you see a commercial of Powerade or Gatorade, those are known as electrolytes. If you have ever been dehydrated when you go to the hospital, at times they put an IV bag that is going to have some solution that contains sodium, potassium, chlorine, and understand that those are sources of electrolytes. Why are they important? As you can see in the slides, they play an important role in maintaining proper function of cells and organs. Specifically, they balance the fluids in your body, they maintain your blood's proper pH, and they carry electrical signals to power nerves and muscles. When it comes to electrolytes, we have 3 different types of electrolytes. The first one is going to be a strong electrolyte. As you can see, a strong electrolyte is going to completely disassociate into ions in an aqueous solution. So that by definition, these are going to be ionic compounds that are soluble in water What that implies is that we're going to have a metal that is going to form a cation and a non-metal that is going to form an anion. So an example of a strong electrolyte, as you can see, is going to be a solution in which we have sodium chloride in aqueous form. One more property of a strong electrolyte is going to be that if you pass a current on a solution of a strong electrolyte and then you try to turn on the light bulb, there's going to be a strong light coming out of that light bulb. Now, when we have a weak electrolyte, understand that these compounds are going to have only a partial dissociation into ions. So if we look at examples of this, for example, HF is going to be one of those compounds that you will have in solution, okay, some anions, you're going to have some cations, and you're going to have some of non-dissociated complexes. Lastly, we have non-electrolytes. And when it comes to non-electrolytes, these are going to be compounds that do not break into ions in solutions. Oh, I should mention that when we have a weak electrolyte and you try to do the same experiment with the light bulb, you only get a dim light. Going back to the non-electrolytes, remember, these are going to be compounds that do not separate into ions. So non-electrolytes do not separate into ions. So they stay as a whole. Interestingly, when you do the same experiment of passing a current, no light is shown. Now we are going to part A in the worksheet. As you can see, we have some terms and we are going to match them with the definitions that we have on the right side. So let's get started. As you can see, number 1 is solution, number 2 is solute, number 3 is solvent, 4 is soluble, 5 is alloy, 6 is aqueous solution, and 7 is an electrolyte. So let's match them with the definitions that we have on the right. Okay? So something that is capable of being dissolved is going to be soluble. So number 4 is A. A solution in water, where water is the solvent, that is known as aqueous. So 6 is B. A substance that is dissolved in a solution, that means that that is a solute. So that is number 2. A substance, so letter D, a substance that is dissolved in water to form a solution that conducts electric current, as you guys just observed, that is called an electrolyte. Specifically, strong electrolytes. Remember that weak can also conduct electricity, but barely. E, which is a solid solution containing 2 or more metals. Remember that that is an alloy, so that's number 5. A homogeneous mixture of 2 or more substances in a single physical state. Remember that that is an equivalent of saying solution, so F is number 1. And lastly, a substance that does the dissolving in a solution, that is the solvent. So those are the answers for part A in our worksheet. So now in section 9.3, we are going to go over the concepts of solubility. As you can see, solubility is defined as the maximum amount of solute that is dissolved in a specific amount of solvent. This concept of solubility can be temperature sensitive, and we're going to see how other factors, including temperature, affects it. And whenever we're talking about something soluble, understand that we can express it as grams of solute divided by grams of water, where water is going to be our solvent, in the case that water is our solvent. Now, when it comes to different types of solutions, as you can see, we can have 2 types. Unsaturated solutions, which means that we have less than the maximum amount of solute that that solvent can retain. So that means that more solute can be added to that solution. And we can also have a saturated solution, which means that it contains the maximum amount of solute that it can dissolve. So because it has the maximum amount of solute, at times, if you go a little bit extra, you can observe that some of the solid, in this case, because that's the physical state of the solute, you can see some solute in the bottom, in this case, of a beaker. Now, there are 2 different factors that can affect solubility. And these factors affect the type of solutions that we have in hand. So as you can see, the first factor that we're going to talk about is temperature. Okay, so solubility specifically of most solid increases as the temperature increases. Okay, in the case of gases, understand that as the temperature increases, then the solubility of a gas decreases. That's why you can observe that hot soda or soda that is retained at room temperature after opening becomes flat faster. In the graph that we have on the right, as you can see, we have a series of ionic compounds that are graphed in terms of how soluble they become, meaning how many grams of solute we are dissolving in 100 grams of water in different temperatures. As you can see, the majority of them, the trend implies, as we have, that in most solids, as you can see, there's an increase in the amount of solute that you can put as temperature increases. So remember that this trend is related to the second bullet point. Now, the next factor that can affect solubility is going to be pressure. And that is defined by Henry's law. As you can see, Henry's law states that the solubility of a gas in a liquid is directly related to the pressure of that gas above that liquid. So what that means is that at higher pressures, more gas molecules will dissolve in the liquid. So utilizing this concept is how we have carbonated drinks. Because remember that in these liquid solutions, the carbonation is going to be in gas form and our solvent is going to be in liquid form.